This is a video just to show you how the graphs of exponentials and logs behave, especially with the graph shifting with h and k values, and we'll also change the base on both the exponential and the log. The first thing you need to know is the basic graph, and so I have an exponential here first. All our exponential stuff will be in this reddish color, and so notice right here I have the point 0, 1. All exponentials behave this way. If I just have 2 to the x, 3 to the x, some base to the x power. Notice what happens with that base. If I make that base bigger, this exponential gets steeper. If I make that base smaller, okay, the closer it gets to 1, the flatter it becomes. If I happen to make it less than 1, okay, but still bigger than 0, then I'll get this downward behavior right there. So 0.2, 0.4, 0.6, any of those are going to have this decreasing look to it. They still go through 0, 1, but they are decreasing now instead of increasing. And once I get past 1, okay, now they start to increase again. So any of those will always exhibit that behavior right there. Now if you want to shift these around a little bit, this is going to have the same shifting properties as our other equations, quadratics, cubics, whatever you like to pick. So if I change this h value that's in the parenthesis, say to 3, okay, so we got 2 to the x minus 3. Notice what happened to our graph. Okay, it was at 0, 1. Now that's been shifted to the right 3 units. So there's a point right there at 3, 1. And this is sort of the turning point, so I get from my flat part here to where it really starts to increase. Also notice the asymptote. So exponentials and logs have this dotted line called an asymptote. For exponentials it's horizontal, and we'll notice that's right there at 0. If I shift this up so that maybe now k is 2, now it's going to be right there at 2. Okay, so that point that used to be at 0, 1 now goes to the right 3 units and up 2 units. So now it's at 3, 3. That horizontal asymptote still right there at 2. If I want to change this a, okay, that'll flip it upside down or right side up around that asymptote. And so if I put a negative out in front, let's go ahead and move that k value down a little bit. Right. So now this is negative 2 to the x minus 3 minus 1. That negative is not included as part of that 2. It's a negative 1 times that 2 to the x minus 3. So that's the basic shifting with exponentials. Let's go and try logs next. Alright, so here's the basic graph of a logarithm, log base 2 of x. And notice this has a point right there at 1, 0. Okay, so remember exponentials and logs, you just swap x and y values because they're inverses. So if the exponential were 2 to the x, the log is log base 2 of the x, and that point that used to be at 0, 1 is now at 1, 0. All the same behaviors apply if I want to shift this to the right. Okay, that's the number in the parentheses, so x minus 2 in the log, okay, that'll give me a shift 2 to the right. That vertical asymptote that goes with the log graph also goes to the right. If I shift this up or down, so that k value changes up or down, vertical lines still look the same when you shift them up or down. So either way, if I move it 2 units down, I get that minus 2 outside the log. So no matter what, okay, remember 3 to the left plus 3 inside that parenthesis, so inside the log. These will always exhibit that same type of behavior. And this is my key point right here, this negative 2 in this case that's been shifted. But anything that starts with that 1, 0 right there, and that's going to be my key point. If I want to flip upside down, okay, I flip around that, and then I can still move these however I want to go. So if I want to go 3 to the left, 2 up, okay, just shifts that way. So 3 to the left used to be at 1, now it's at negative 2, and then 2 up, and then I draw it upside down from that point. So hopefully this gives you sort of an intuitive idea of how these exponentials and log graphs shift.